This presentation on industrial cybersecurity, creating a secure process control environment by properly managing risk, is brought to you by Honeywell. The increasing complexity of process control technologies, coupled with an evolving industrial cybersecurity threat, demands a defense-in-depth approach to thoroughly manage security risk. Although risk mitigation has always been a crucial part of business management, today's process end users experience more serious and growing challenges. According to McAfee, 10 out of 10 facilities lack a robust, supported security maintenance program. The annual financial cost of global cybercrime has reached $114 billion. In the past year, 80% of water, gas, and energy firms reported compromised security systems from hacker attacks, and the cost of downtime for major security breaches is a staggering $6 million per day. Advances in control system platforms and business applications allow end users to leverage new capabilities to improve plant operations. They enable data visualization, creating a tighter linkage between business and process information. By deploying these advanced technologies, plants can improve system availability, reduce operating costs, and achieve greater production yields. Today's control systems have moved from proprietary platforms to more open technology and allow commercial off-the-shelf solutions to easily be integrated. These open technologies invite accessibility, and individuals and groups within the organization want access to perform their own functions in a more timely and effective manner. So while these technologies bring unmatched opportunities, they may also expose production facilities to increased industrial cybersecurity risk. While businesses of all types need a defined strategy to mitigate threats, vulnerabilities not addressed in a process control environment could produce disastrous consequences. The introduction of a virus or malware can bring production to a costly halt, or in more extreme cases, cyber espionage can result in a plant explosion. Production facilities pose a greater industrial cybersecurity risk because of the following: hard to find technical talent and a lack of staffing resources to manage industrial cybersecurity, a greater emphasis on uptime, availability, and reliability at the expense of more stringent industrial cybersecurity practices, an increased requirement for accessibility. More and more company personnel need access to companies' IT resources from any location 24/7. Numerous and complex tools, standards, and best practices make it more difficult to select the most appropriate industrial IT solution. Lack of critical lifecycle management in the industrial IT environment. Integrated business and production systems require careful design and infrastructure to ensure selective access and security. Just as corporate IT organizations have tackled the risk issues by deploying a consistent, proven set of tools across multiple systems, individuals in a control systems environment must adopt a similar approach. Production facilities need to understand that industrial cybersecurity risk mitigation requires an ongoing, long-term, and sustainable program, not a project that has a defined completion date. To safeguard a process control environment, a comprehensive industrial cybersecurity strategy that combines tools, services, best practices, and expert support is needed throughout the IT lifecycle. By addressing the phases of each lifecycle, industrial companies can avoid the issues associated with changing business strategies, new technology deployments, escalating user demands, and more. To address the 4 phases of the IT lifecycle, the phase 1 is assess. Often the most informative phases of the lifecycle, the assess phase evaluates assets and vulnerabilities against industry standards, regulatory requirements, and best practices. After identifying risks, the solution provider develops a roadmap to remove all threats to the industrial process control system. Phase 2 is remediate. This phase tackles the threats identified in the assess phase. Industrial IT solutions need to focus on delivering a customized industrial cybersecurity program. Specifically, the program must minimize vulnerabilities to cyber attacks, improve system performances, and lessen the impact on any security breach. Phase 3 is manage. During the manage phase, the focus is on keeping the network and security programs operating at peak levels. Industrial companies require ongoing management of their systems and technology to meet production, availability, and regulatory requirements. For example, this phase would include workflow implementation, antivirus and patch managed services, network perimeter management, and managing system changes. Phase 4 is Assure. Program monitoring helps assure the network and security program function as designed and per regulations. Activities during this phase include verifying patch installations and an antivirus update, tracking compliance requirements, and reporting regularly on system performance. While setting up a cybersecurity program and running it on an ongoing basis may appear overwhelming, it's key to safeguarding against security breaches and cyber attacks. Breaking down efforts into the 4 phases of the IT lifecycle demystifies what's needed to establish and maintain a robust defense. An effective strategy helps unite the best practices of traditional IT with the special requirements of process control systems. The end result is greater control over the production environment while delivering maximum system performance. About the author. Rick Kwan is a global industrial IT solutions business development lead for Honeywell Process Solutions, a pioneer in automation control for more than 35 years. For more information about industrial cybersecurity, please visit www.honeywellprocess.com today.